Imagine this. You blink, and suddenly the universe forgets what moment you're supposed to be in. Because that, right there, is the forbidden doorway called time travel. And today, you're going to step through it. Not with a machine. Not with magic. But with the raw, terrifying logic of physics, paradox, and the cosmic speed limit that reality itself tries to hide from you. Time isn't a river. It isn't a clock on the wall. Time is a fabric so delicate that every moment you experience is stitched into place by the laws of motion, gravity, and energy. And if you tear one thread, the entire tapestry trembles. Every second you live is a coordinate in space-time. A cosmic address. The universe knows exactly where you belong. But what happens when you try to leave that address? By going forward or backward? What happens when you try to outrun light itself? You get paradoxes. Impossible loops. Events that cancel themselves. Realities where cause and effect fight like predators in the dark. But start with this, time travel is not fantasy. It already exists. Every astronaut in orbit is traveling into the future faster than you. Every GPS satellite is operating in a slightly different timeline because gravity bends time like a blacksmith bending metal. Even you, right now, have time dilation happening in your bloodstream. You age differently on a mountain than at the sea level. Tiny differences, microscopic cracks. But cracks lead to openings, and openings lead to doorways. And if doorways exist, someone, someday, is going to try to break them open. Now imagine you're in a ship, no, not a spaceship, a thought ship, accelerating faster and faster. As your speed increases, time slows. Your heartbeat stretches. Your seconds expand. Push harder. Faster. Near 90% the speed of light, the universe outside starts aging while you're barely moving. Go even faster. 99%. 99.9. Stars blur into streaks. Time outside your ship screams forward like water bursting through a dam. At this moment, you are no longer living in the same storyline as everyone else. You are drifting into tomorrow while they remain trapped in today. Congratulations. You've become a time traveler. But then comes the forbidden idea. The idea that makes physics curl its teeth and growl. What if you go faster than light? Suddenly, everything collapses. Because crossing that speed doesn't just rip through space, it rips through cause and effect. It twists the sequence of events until the universe can't tell what is supposed to happen first. Faster than light travel means your arrival can be detected before your departure. You fire a beam. And the target receives it before you shoot it. You send a message. And your past self gets it before you press send. You leave home. And you arrive before you even pack your bags. This is where paradoxes bloom like deadly cosmic flowers. The grandfather paradox: if you go back in time and stop your ancestors, you erase your own existence, which means you never went back, which means they live, which means you exist again, which means you go back again, an infinite loop that breaks logic in half. The bootstrap paradox: you give someone a piece of information from the future. And that person becomes the reason it exists in the first place. A book with no author. A machine with no inventor. A story with no beginning. The predestination paradox: you try to change the past. But your attempt becomes the very reason why the event happened. Destiny swallowing itself. And it all gets worse when faster than light enters the equation. Because going faster than light lets you outrun information. And information is the backbone of causality. If effects outrun causes, reality collapses into impossible sequences, time loops, and events that contradict each other. Physics allows time travel only when cause is preserved. But faster-than-light motion is a direct attack on causality. Think of space-time as a giant grid. Light defines the maximum slope you can climb. If you break that slope, you're not just going sideways, you're sliding backward into the grid, landing in regions the universe didn't permit you to enter. Regions where your future self can shake hands with your present self. Regions where messages can arrive before they're sent. Regions where reality can't decide which version of you is the real one. And so the universe sets a rule. Nothing with mass can reach or exceed the speed of light. Not because it's too fast. But because the moment something breaks that limit, the story of the universe becomes unreadable. Yet here's the twist. Modern physics whispers hints, tiny, forbidden hints, that time travel may not be impossible, only locked behind conditions so strange they feel like riddles. Wormholes, shortcuts through space-time that might let you jump between moments if you could stabilize them. Cosmic strings, infinitely thin defects that bend space-time so drastically that closed loops of time might exist near them. Quantum foam, the microscopic jitter of reality where time might not flow in a straight line at all. All of these are theoretical, wild, untamed. But they show something important: time is not as rigid as you think. It bends. It flexes. It can be distorted. It can be manipulated. But it punishes violators who try to break its most sacred rule: maintain cause and effect. So what is time travel? It's the art of bending the sequence of events. It's the rearrangement of before and after. It's the ultimate rebellion against the flow of reality. What is a paradox? It's the universe screaming that something has broken the rule book. It's physics refusing to accept a storyline that contradicts itself. It's a warning sign flashing across space-time. You cannot do that. And why does faster than light cause time paradoxes? Because when you outrun light, you outrun information. When you outrun information, you outrun cause. And when cause collapses, time breaks. But here's where your journey becomes thrilling. Because the universe doesn't say time travel is impossible. It says reckless time travel is impossible. It says paradoxical time travel is impossible. But controlled, predictable, safe manipulation of space-time? That's another story. Maybe one day we'll learn to surf gravitational waves like cosmic surfers. Maybe we'll learn to twist space-time gently instead of tearing it apart. Maybe we'll build engines that slow time, stretch time, or redirect it. Maybe we'll discover that paradoxes don't destroy time, maybe they reveal deeper rules we can't yet see. Imagine stepping into a device not to break time, but to negotiate with it. Not to force a paradox, but to glide along the edges of causality. Not to rewrite the past, but to explore the untouched corners of the future. Into this journey, and your mind is now a rocket soaring across the timeline of reality. You've felt time slow. You've watched paradoxes twist. You've stared into the cosmic speed limit and understood why the universe guards it so fiercely. But the biggest truth is this: time is not an enemy. It's not a wall. It's a dimension, one we barely understand, one we can't yet control, one that might hold secrets bigger than galaxies. But before we step out of this journey, before we let go of the edge of space-time that we've been clinging to, there's one last truth you need to feel, not just hear. Time is not a straight line. It's not a cage. It's a living, breathing ocean. And every moment you experience is a wave rising, breaking, and dissolving into the next. And maybe, just maybe, we are the only species in the known universe foolish enough, curious enough, brave enough to try to surf that ocean. Not because we want to change the past, but because we want to understand why it exists at all. Imagine the moment humanity finally builds the first engine that bends space-time like a musician bending a note. A machine that whispers to the universe, "We're not here to break your rules. We just want to see how deep the rabbit hole goes." That day, the universe won't scream. It won't collapse. It won't panic. It will listen. Because the story of existence has always been a conversation, galaxies speaking in gravity, black holes speaking in silence, and humanity speaking in questions. Where does time begin? Where does it end? Does it loop? Does it branch? Are we travelers or prisoners? Are we explorers or participants? Or is time simply waiting for us to evolve enough to understand its language? And when our first ship rides along a gravitational wave and dips into a moment 5 seconds ahead of our own, the world won't end. It will open. A crack of light. A whisper of possibility. A glimpse of a future no longer locked behind the speed of light. Maybe we'll travel to the edge of a black hole, where time slows to a crawl, and watch 1,000 years pass outside while only minutes pass for us. Maybe we'll drift through wormholes stabilized by physics we haven't even invented yet. Maybe we'll discover that paradoxes aren't barriers, they're signposts pointing toward dimensions where cause and effect aren't the rulers, but partners. And maybe, just maybe, one day someone will return from a journey into the far future with a single message carved into their suit: "We made it." We don't know what the future holds. We don't know if time travel will remain theory or become technology. We don't know if paradoxes will remain warnings or become tools. We don't know if faster than light travel will stay forbidden or become the spark that ignites the next era of humanity.